Hello and welcome to a new video of Web3 hacking and development tips. Today's challenge is about learning the core of ERC20 token standards. So without any further ado, let's start. Here I'm in the isolated environment of this challenge. We have the contract source called HEMS dummy token. So I would like first before proceeding to clarify something. It is one of the biggest misconceptions in the Web3. Most people think that the tokens are stored in their wallet, which is not the case. Your wallet doesn't actually hold your ERC20 token or TRC tokens or whatever. The wallet simply stores the private key, which proves ownership of a blockchain address. That's it. So the token balance are recorded inside the smart contract that created this particular token. For example, here let's go down to this function transfer. It's internal, which means it's only called within the smart contract. It cannot be called from outside. So there we have transfer from that calls this function. But let's focus on this function transfer. So here we have a balance of from the address of the sender, okay, minus the amount that he wants to send, the amount that the sender wants to send. Balance of to the receiver gets the balance that the sender wanted to send. That's it. That's how it happens all the time. For example, let's take one of the famous tokens, USDT. It's a stable token, centralized also token. Why? This one particular function that proves that you do not hold the tokens. On the USDT smart contract, if you go fetch USDT smart contract on Ethereum, on Etherscan, and go to the panel read contract, you will see blacklisted. For example, USDT have the possibility to blacklist a wallet, so that wallet in particular cannot move the funds or do anything. You cannot do anything with the funds that you have, the assets of USDT that you have in your wallet. So, which means that the smart contract controls everything related to a particular token. Now let's see what this challenge demands us to do. The first thing, we need to check the wallet balance, enter any wallet address below, and call the getBalance function to retrieve each HEMS dummy balance or use the provided script. We have scripts, I believe, here. Yeah, get balance. Okay, I'm going to do it on the here. So we need to find the address that minted the first tokens. So we have to like take this one, go back here and see if this address is the contract owner and the address that minted the token. Check balance 0. Okay, let me take a look on the mint function internal. Approve transfer. The function, it's internal, and I think it's called only one time by the constructor. Yeah, so the amount was minted only one time, so this function cannot be called again, and no more tokens can be minted. So let me take another address to check which address minted and deployed the contract. I think, let me see this one. Check, yeah. Okay, so this is the one that deployed and minted, and it holds, this is in decimals, this amount of the dummy token and the smart contract. Okay, so now as we discovered which address, we need to make a transfer to any wallet in the list below. So to make a transfer, what do we need? We need to interact with the smart contract. Take its API, call this function transfer from. So as we know, which is the owner and the first wallet to mint this amount of tokens. We have its private key down, so we can use that wallet and transfer some of this dummy tokens to another wallet. And everything will be recorded on this smart contract. Here we have our Python code to make the transfer from the owner wallet to another wallet. Okay, you have to choose a wallet from the provided wallet on the smart contract viewer, this one of these wallet. So let's start. Here we connect to our RPC endpoint. We have our contract address. We need our wallet, the private key of the wallet, and the receiver. We need the ABI. We need to load our ABI. Show ABI, copy. Close this. Go here. We paste our ABI so we can interact using this ABI with the smart contract. Okay. We need the amount that we want to send. I'm going to send 100 GWay. We need the contract instance to create the contract instance, the contract address with the ABI loaded, and we need to call the transaction transfer from. Why I have two ABI instances here? Contract instance, we need only one. The transfer from, we input the wallet from to receiver and the amount. We build the transaction. We are going to willing to spend 150K in gas and 0.8 GWay gas price per gas unit. The nonce for the transaction count of the wallet and the chain ID. We sign the transaction with the private key with this function and we send it. So let me run this code, transfer.py, and this code will not work, and I'll explain why shortly. Okay, so what's the reason? Exception Web3 RPC error reverted with reason allowance exceeded. What does it mean? If you go back here to the contract, let me put it full screen. Where is it? We have a require allowance to spend a particular amount. Okay, and here we have the function approve. What does it mean? It means that we need to approve to spend a particular amount of token. So we need here to call this function with our address, the wallet that has this token, to approve spending some amount of token so we can transfer it. The thing is, I would like to mention something. Some people sometimes wake up to find their assets are gone, and they are sure they did not initiate any transfer. What happened exactly? That they interacted with the malicious web application. They used their wallet to sign, to connect to that web application. Meanwhile, they approved a malicious smart contract to spend on their behalf. This is what happened exactly. They gave permission to a malicious smart contract behind that Web3 application to spend their token. And they end up with a zero in USDT, in USDC, whatever token they have in their wallet. So this is one of the most common social engineers techniques that hackers, I would not say hackers, scammers use to trick people to steal their funds. This particular function approve. So we need to call this function approve, okay, to approve spending some amount of GWay, and then we're gonna send it. Here we have the Python script to call the approve function. It's almost the same as the other one, but I'm going to change this one to approve. And my wallet and the amount. We don't need the receiver. If you go back here to our dummy token contract, we need the address of the spender and the amount that we are willing to spend. We go back here, okay, approve. And we are willing to approve spending 100 GWay. Okay, let me check. We don't need receiver, I removed it. What else we need? So let's run this code, Python approve. So we have a hash of the transaction. We approved to spend 100 GWay. Now, if we go back to transfer and make the transfer of this amount, it should work now as we approved ourselves to spend a certain amount of token. If we do transfer and the transaction went through, if we go back here to our contract and we can see the flag is showing, we transferred some token to this address. Let's take this address, paste it here, check the balance, and we have the amount transferred to HMS dummy transferred to this wallet. So regarding this, I did not talk about this 9, the decimals, GWay, the Ethereum. There is a website called ETH Converter, I think. It will explain to you what is the difference, how to convert from GWay to Ethereum to Finate to many different units of the Ethereum network. Thank you guys for watching, and I will see you soon in another video.